part B. Okay, so in part B, it's a little bit different. It says, if the couple decides to withdraw $3,000 a month until the balance in the account is zero, how many withdrawals can they make? Okay. All right, so it's a little bit of a flip here, okay? So like when you retire, you know, you can think about your account in a couple of different ways. You can do what's going on in part A. You can say, okay, I've got this set amount of money and I need to receive payments for, you know, monthly for the next 10 years. How much can I withdraw every month? On the flip side, you may say, okay, I've got my nest egg, okay? I need $3,000 a month to live on, okay? How long will this account keep me going? Okay, so it's just two different ways of, you know, timing wise, looking at how you can be supported throughout retirement. Okay, okay, so again, they still have the set $200,000. So we're kind of, you know, ignoring part A. This doesn't have anything to do with part A. You're going back to the original premise of the problem where the couple has $200,000 in their account. Okay, and this time they know they're going to take out $3,000 every month until there is a zero balance. Okay, so again, they have $200,000. They're going to withdraw $3,000 every month. The money that is in the account still is going to earn interest. Okay, so you have to use a formula on this. Okay, so now it's kind of timing wise. Okay, if they take out $3,000 a month, how long can they keep this up? All right, so we're still going to use our present value formula. So let me go ahead and write it down again. Okay. Like I said, this is an annuity being paid out. We are receiving the payments here. Okay. All right. So here's our formula. Okay. We still have the same interest rate. We still have the same M value. Okay. T is what we're looking for here. Okay. Because it says kind of, it doesn't directly say solve for time. But we're trying to figure out how many withdrawals can the couple make, okay? And that is tied to timing, okay? How long can they keep this up if they're pulling out $3,000 a month, okay? All right, so let's see. We should know P and PV at this point, okay? Again, the present value of this annuity. How much does the couple have right now? They have $200,000, okay? And each payment to them is going to be $3,000. So that's the P value. Okay, so these are the values of the variables. So we're going to go ahead and plug everything in. Okay, so I'm going to get 200,000. Let me write it right here. So we're going to get $200,000 is equal to 3,000 times all this stuff. So let me just write it up. All right, so the unfortunate part of this problem is now you have to solve for time. Oops. All right, there you go. So that's how you set it up. Okay, and again, we're having to solve for time. Okay, we need to know how long they can keep this up to make, you know, so many withdrawals. Okay. All right, so this is probably going to be our first instance of solving this problem for time, or solving this formula for time. Okay. It's a little bit tricky here because you've got a negative exponent here. But again, our whole goal is to isolate the quantity that has the t, okay? So t is in the exponent. So again, you're going to have to use a logarithm at some point, okay? But first, we need to isolate this quantity in parentheses because it contains the t, okay? So the first thing I'm going to do is we're going to divide both sides by 3,000, okay? So, because, you know, this thing that we're trying to isolate is in the brackets, okay? This 3,000 is outside the brackets, so we can easily get rid of it, okay? Everything in brackets is being multiplied by the 3,000, so to undo that, we're going to multiply both sides, or sorry, we're going to divide both sides by 3,000, okay? So I'm going to come up here. All right, so let's get our calculator here, okay? So we're going to do 200,000 divided by 3,000. Okay, And look, that's going to give us a really nasty decimal, okay? The sixes are going to repeat. You would have to carry all the digits. So what I'm going to do is I'm going to leave this as a fraction, but I'm going to go ahead and reduce it. If you hit your math button right here, the math button, okay, math, the first option is to convert that decimal to a fraction. So just hit option 1, okay, and then hit enter. And the reduced fraction is 200 over 3. So that is what I'm going to work with instead of having to write those, worry about the decimal places. Okay. So 200 divided by 3 is going to be equal to all this stuff that we had in brackets. Okay. When you're doing a problem like this and the formula is really complicated, you really want to write everything down. Okay. Don't try to do like 2 or 3 steps at once. Okay. One thing at a time, you are less likely to make a mistake. Okay. All right. Again, I am trying to isolate this guy. Okay. Because it has the T. Okay. So what we're going to do now is we are going to deal with this thing in the denominator. Okay. So I am dividing by the quantity 0.0 or the quantity R over M. And so to undo that, I'm going to multiply both sides by R over M. Okay, so out to the side over here, I'm going to put times 0.084 divided by 12. Okay, whatever you do to one side, you have to do to the other. So I'm going to multiply this side by 0.084 divided by 12. Okay, so what's going to happen over here is you're going to have 1 in the bottom and 1 in the top, and they will cancel. Okay, so over here, I guess I'll just go ahead and plug it into my calculator because, you know, it's going to start getting messy. All right, so the left side here is going to be 200 divided by 3 times 0.084 divided by 12. Okay. Again, I got a nasty decimal. You can try to convert it to a fraction and see if you get something nice. Okay, so I'll do math, convert to fraction, and I actually did. I got something nice. So the left side is 7 over 15. Okay, so we're going to get 7 over 15 is equal to, okay, this R over M canceled with the one that we multiplied by. Okay, so we're going to get this is equal to 1 minus 1 plus 0.084 divided by 12 to the negative 12t. Okay, so we're getting there. Okay, so again, just to recap all I did in this previous step, okay, I am trying to isolate this thing that I have underlined, the quantity in parentheses. Okay, since we were dividing everything by R over M, I did the opposite, so I multiplied by R over M so that I would have 1 in the top, 1 in the bottom, and they would cancel. Okay, but since I multiplied by R over M on the right side, I had to do it on the left side. Okay, I put this in the calculator and converted it to a fraction, and now I have 7 over 15. All right, we are still after isolating this guy. Okay, so we can get rid of this 1. Okay, the 1 is positive. This is positive 1 minus this stuff. Okay, so to undo this, we have to subtract 1. Okay, so whatever I do to the left, or sorry, to the right, I have to do to the left. Okay, so let's go back to the calculator. Okay, we're going to do 7 over 15 minus 1. Okay, convert it to a fraction. Okay, this is going to be negative 8/15. Okay, is equal to, the 1's cancel. I still have this negative sign outside the parentheses. Okay, be very careful. There's a lot going on here. Okay, all right. We are still after isolating this guy. Okay, so what I need you to realize here, okay, both sides are negative. Negative 8/15 is equal to this negative quantity. Okay, so we need to, make both sides positive. Okay, we're going to go ahead and divide both sides by -1 or multiply both sides by -1. Okay, so we'll get positive 8/15 is equal to the negative divided by negative will cancel, and you'll get positive on the right side. Okay. All right. So now this quantity is isolated, the thing in parentheses. Okay. So remember, this is exponential. You're solving for t. T is trapped in the exponent. Okay, so you're going to have to use a logarithm, but before you can apply the logarithm, you had to isolate the quantity that contained the t. So that's the stuff in parentheses. Okay, so now it's isolated, so we can take the logarithm. Okay, so I'm out of paper, so let me go to a new sheet of paper here. All right, so let me write down what we had. Okay, so we had, hold on, we had, put the problem number. All right, so we had this quantity. This just left us with 8/15 is equal to 1 plus 0.084 divided by 12 raised to the negative 12t. Okay, again, this is isolated. This exponential piece is isolated, so we are ready to apply the logarithm. Okay, so I'm going to take the natural log of both sides. Okay, remember, natural log or any logarithm is something you do to a number or quantity, okay? So it goes on the left side. It does not make sense on the right side, okay? So if I do it to the left, I've got to do it to the right side. Okay, so here we go. All right, so I took the logarithm, okay? Remember what we talked about when we did this in earlier sections, that if you have the logarithm of something to a power, you can bring that power down in front, okay? But you can only bring that power down in front if you apply the logarithm, okay? You can't do that if the logarithm is not there, okay? So in the next step, we're going to have the natural log of 8/15 is equal to negative 12t times the natural log of 1 plus 0.084 divided by 12. Okay? All right. This is just a number. It's going to be a nasty decimal. This is just a number, nasty decimal. Okay? Like we did in sections 3.2 and 3.3, you're going to want to solve for 12t, not just t. Okay? So we are going to go ahead and divide off this number, this logarithm, okay, because we need to isolate the negative 12t. So we're going to go ahead and divide this off. Okay, whatever you do to one side, you have to do to the other. All right, so here we go. On the right, these guys will cancel. Okay, so we're going to get negative 12t is equal to this stuff. Okay, so I'm going to go ahead and punch that into the calculator to see what I get. Okay, let's see what we get. We're going to get natural log of 8/15 divided by natural log of 1 plus 0.084 divided by 12. Okay, so that's going to be this nasty decimal. I'm going to go ahead and write the whole thing down for you. Okay, so we're going to get negative 12t is equal to negative 90.11517598. All right, notice both sides are negative, okay? That makes sense because if I divide both sides by -1, then I get positive quantities, okay? You don't want to end up with negative time, okay? If you had a negative on one side and not the other, that wouldn't make sense because it would indicate a negative time value, and you do not want to have that, okay? All right, so we're going to stop here, okay, and interpret our answer, okay? Remember, because the 12 is in front of the t, this is indicating the number of months that this couple can make withdrawals, okay? We learned in 3.2 and 3.3 when we were saving money that you should round up time. So you should, like if you were saving money, you would round up to 91 months here just to ensure you have enough time to save the money, okay? Since we are withdrawing money, it's the opposite here. You round down, okay? Think about this. This is indicating how many months they can make withdrawals. 90 whole months. It's not, it hasn't made it over to 91 yet. So because they're withdrawing money, you have to round down. They can only withdraw money for 90 full months, okay? It doesn't get to 91, okay? So we're going to round down, okay, because we're withdrawing money, okay? So the couple can withdraw money, or the $3,000 every month for 90 months. Okay, so remember the question asked how many withdrawals can they make? Okay, well, they're making monthly withdrawals. Okay, so we're going to write the couple can make a total of $93,000 withdrawals. Okay, that will bring the account balance pretty much to zero. Okay, so 90 is the answer here.